Welcome. In this video, we're going to take a closer look at the half equations or the half reactions in a redox process. So even though oxidation can't happen without reduction, and reduction can't happen without oxidation, we often separate the redox reaction into the two half equations to see what's being oxidized and what's being reduced. Also, the half equations are used to balance redox reactions because inspection doesn't always work. We can't always tell if the electron transfer is equal or not based on balancing by inspection. So electrons are added to the more positive side of each half equation to balance the charges. So that means electrons are added to the reactant side of the reduction equation, and electrons are added to the product side of the oxidation equation. Because remember, in chemistry, we don't subtract, we show the before and after. So electrons are gained in reduction, lost in oxidation. So if we look at an example here, it says write both half equations for the following balanced equations, including electrons. Decide which species is oxidized and which is reduced. So if I start with my first one here, I've got... So the two equations we just looked at were both balanced, but how do you use half equations to do the balancing? Well, the first step is to assign oxidation numbers to all species, then write the half equations, and then you're going to balance the half equations. And this is where it gets a little bit tricky. You balance the half equations by inspection for the atoms other than hydrogen and oxygen. And then if one side needs more oxygen, instead of using coefficients like we did previously when we've balanced equations, you add H2O till you have enough oxygen. That, of course, is going to goof up your hydrogen, so then you add H plus to the opposite side until you have enough hydrogen. And then finally you balance each for charge by adding electrons to the more positive side. Finally, before you add the two half equations together to get your balanced redox equation, you have to equalize the total number of electrons in each half equation. So it might mean you have to multiply one of the equations by 2 so that they have a like number of electrons being gained and lost. Or you might have to multiply them both, 1 by 2 and 1 by 5 for a least common multiple of 10. At that point, you should be able to add the half reactions and cancel like terms. And then I always like to suggest you double check for a balanced reaction in terms of both atoms and charge. So here's a couple reactions that balance easily by inspection, but instead I'm going to use the redox half equation method so you can see how it works. So I have Mg metal. It's got a 0 charge, a 0 here. This is going to pick up a +2, which means the nitrogen is going to pick up a -3. So Mg becomes 3 Mg ions with a +2 charge, which means I need 6 electrons total for that to occur. I also need a 3 on this side. My N2, on the other hand, becomes 2 nitrogen ions with a -3 charge. I am balanced with my nitrogen, N2 and 2N, and this needs a total of 6 electrons to be gained over here. So now when I add, I've got 6 electrons gained, 6 lost. I can go ahead and add my equations. I have 6 electrons, 3 Mg, N2, 3 Mg2 plus, 2N minus 3, and 6 electrons. I cancel out my 6 electrons, and indeed 3 Mg plus N2 would give me Mg3N2 if I go ahead and put my ionic compound back together. Looking at the second one then, I have aluminum metal becoming aluminum ion with a +3 charge. That means there was a loss of 6 electrons or loss of control. On the other side, I have Cl2. These are both 0. I should have written my oxidation states in, +3 -1. Cl2 is going to become 3Cl minus. So now I need to balance. I've got 3 and 2, so I'm going to need a 3 here, and this is going to have to become a 6. That means there were 6 electrons that had to be picked up over here. That also means this needs to be doubled. So when I add this up, I've got 2Al plus 6 electrons plus 3Cl2 yields 2 Al ions plus 6 electrons plus 6 chlorine ions. And again, when I cross out my 6 electrons, I am left with 2 Al, 3 Cl2, and then 2 AlCl3. On the second try, I've got more complicated equations for you. Well, you'll have to use oxygen in the form of water and then hydroxide ions to balance. So if we look at the first one and assign oxidation states, oxygen is going to be a -2, which makes the nitrogen a +5. Copper's elemental, so it's 0. On the other side, oxygen's still a -2, so nitrogen's a +2. And the copper has now become an ion, so its oxidation state is also +2. So looking at the nitrogen, NO3 minus becomes NO. I have a reduction of +5 to +2 in the nitrogen, so that means my more positive side is the reactant side with the +5, and I need 3 electrons. My nitrogen is balanced. My oxygen is not, so I add 2H2O to balance that out. And then that means I also need 4H plus on this side to balance the hydrogens. So then for the copper, I have Cu becoming Cu ion. So that just needs the 2 electrons, and that half reaction is balanced. Now I've got 3 electrons being gained and only 2 electrons being lost. So I'm going to have to multiply this equation by 2 and this equation by 3. So when I do that, this will become 3 Cu, 3 copper ions, and 6 electrons. Up here, this will become 8 hydrogen, 6 electrons, 2 NO3 minus, 2 NO, and 4 H2O. So when I add my equations together, I'm going to have 8 H plus 2 NO3 minus, the 6 electrons are going to cancel out, that was the whole point, plus 3 Cu is going to yield 2 NO plus 3 Cu2 plus 4 H2O. And if I look, I've got a +6 charge on my product side, the 3 copper at a 2 plus each. And on my reactant side, I've got 2 minus from the NO3 with the 8H plus. So my charge does balance, +6 on each side. And then when I look at my atoms, I have 8 hydrogen on each side, 2 nitrogen, 6 oxygen, and the 3 copper. So I am balanced in terms of both atoms and charge, and my number of electrons transferred was equal. So let's look at the second one, NH3. Sorry about the squiggle there. I've got hydrogen at a +1 each, which makes my nitrogen -3 in this case. Oxygen's a -2, so the PB must be a +2. On the other side, nitrogen's going to be 0, and PB is going to be 0. Now, I already know I have some issues because I don't see any oxygen on the reactant side, but we'll take care of that. So if I look at the NH3 is going to become N2, and I leave it together because it's a molecule. And I'm going from a -3 to a 0. I'm going to need a 2 here to balance the nitrogen. And that means I'm looking at a total of, from -3 to 0, that's 3 electrons each, or a total of 6 electrons for 2 nitrogen. Now I have hydrogen on the left side, but not the right, so I'm going to go ahead and add my 6 missing hydrogen. So with my PBO, it's just going to form PB, so my PB are balanced. I'm going from a +2 on the left side to a 0, so that means there's 2 electrons being gained over here. I'm going to need an H2O to balance it, which means I'll need 2H plus on this side. I'm also going to have to multiply this whole thing by 3 to have enough electrons. So that makes this 6H plus, 3 PbO, 3 Pb, 6 electrons, and 3 H2O. So now when I go ahead and add my equations, my electrons cancel out.